I would like to present this project, which is in the frame of the LIFE program of the European Commission. And the name of the project is New Generation of Biocomposites based on olive fibers for industrial applications. This project is active in the period from 2019 to 2023 and has a total cost of around 1.7 million euro. It is 55% funded. The main idea of this project is the revalorization of the pruning waste from olive oil industry into new bioproducts for different sectors, such as automotive and furniture sectors. And the idea is to follow a circular economy strategy, highlighting a double benefit. On the one hand, we want to avoid the burning of the waste in the field. And on the second hand, we want to substitute fossil fuel-based raw materials by this biomass. On the right side, you can see small, but you can see more or less where are located the partners of this consortium for the project. So we have a partner in Germany, two companies in France, and the rest are in Spain. So the leader and the coordinator of the project and the consortium is the technological center called Andaltec, which it's in Andalusia. So that is the name from Andalusia, Andaltec. And as partners, we have some companies. In Germany, we have a research center of Ford. We have in France two partners, Plasturgia and Caliplast. And in Spain, we have a small company, Matricería Peña. And these companies are the industrial end users. Also, we have the University of Jaén as a partner in the project, and the Foundation COMP0LIVE, also in Jaén, which is related to olive technology. So the main problems that we want to tackle in the project can be divided in 5 main problems. First, the more than 7 million tons of olive pruning are generated in Europe per year. This is a huge amount of biomass without taking advantage of this. So the proposed solution to this situation of this high amount of waste is that is the revalorization of that olive pruning waste. And how we can do that the answer is by demonstrating that this pruning waste can be used as a polymer reinforcing agent. On the other hand, a part of this olive pruning is burned every year in the fields, and this provokes greenhouse gases emissions. So our idea is to achieve around 20 tons of olive pruning per year used in these biocomposites. For that quantity of olive pruning, we can obtain around 15 tons of fiber per year. So the olive fiber, the quantity of olive fiber will be lower than the quantity of olive pruning due to the efficiency by processing the olive pruning. And we will we expect to incorporate up to 40% in weight that natural fiber in the composites. On the other hand, from the point of view of the industry, there is a huge demand of fossil-based plastic in the automotive and the furniture sectors. And we propose the substitution of those fossil-based raw materials by bio-based materials. And we propose in the project the creation of 3 new business models based on the efficient management of that olive waste. From a different point of view, not from a technical point of view, at the moment, there is a low consent in the primary sector, in the agricultural sector, of taking advantage of that olive pruning waste. And this is a problem because we don't use that waste for anything. The proposed solution is to encourage the agricultural sector to take advantage both economically and also eco-friendly, in an eco-friendly way of that olive waste. And for that, we will perform dissemination activities to engage farmers. For example, in the following COMP0LIVE fair in Jaén, we will present also this project to the agricultural sector, to the farmers. And also there is a low political consent about the importance of the use of this olive waste. So we propose changes in the legislation in order to encourage the use of this pruning waste. So we expect to have meetings with policymakers, and we have already had meetings with authorities and representatives of administrations. And also we want to have these opportunities at European levels. This is for future work. And so once seeing those problems, we expect the following results. From the environmental point of view, we expect the revalorization of the olive pruning residue and the creation of a sustainable material with a high content of bio-waste, as I said before. From the techno-economic point of view, we have already developed 8 different biocomposites at laboratory scale, and 4 of them are to be later scaled up. We expect also to scale up the manufacturing of olive fiber-based composites. For future work, we will manufacture 3 real prototyping demonstrators. And moreover, we expect to transfer to different stakeholders the advantages of these biocomposites. From the social point of view, we expect that after this project, we have more implication of the primary sector and also from the policymaker people, and we will do that through the different dissemination activities. So the project can be divided in 4 main phases or stages. We are already in the second one. In the past, at the beginning of the project, we worked in the olive tree pruning by the collection, the transport, and the storage of the pruning. Currently, we are working in the biocomposite manufacturing. So for that, we we perform the fiber treatment, chemical treatment, and the compounding with the polymer matrix. And now we are working currently in the scaling up of the biocomposite production. Then we will characterize those biocomposites. So on the one hand, we have the manufacturing of the biocomposite at laboratory scale, but one of the main tasks in the project is to scale up that process. Then we have the stage of the manufacturing, and we will have prototypes, and we will have to validate them. Those prototypes are related to 3 different kinds of products. Some parts in the automotive sector, also parts for home furniture, and parts for urban furniture. And then in the last stage, we have the market stage. We will analyze the replicability and transferability of those results, because these advantages of the olive pruning waste can be applied to other different sectors. So in the technical part, the action B1, material selection and biocomposite development, we have one main objective, and it is to obtain at least 8 biocomposites at laboratory scale, fulfilling the requirements of the industrial users. So it wasn't easy to fulfill those typically mechanical requirements. So, but it is already performed. That this action was divided in 4 sub-actions: B1.1, selection of the polymer matrix and fiber. And the polymer matrix can be of two types. We have used bio-based polylactic acid and also recycled polypropylene. And we selected the polymer matrix and the fiber depending on the application. So the fiber was selected in terms of size and content. The sub-action B1.2, we apply the chemical treatment and we characterize the fibers. In the sub-action B1.3, we developed the biocomposites through the compounding, and we also improved the compatibility with the desired polymer matrix. And the final sub-action, we characterized the biocomposites in terms of mechanical, thermal, and physical chemical properties. So in the first sub-action, we began by the pruning collection. We characterized the pruning, we determined the percentage of leaves in the pruning. We did the grinding of that biomass, and we characterized also that the composition of the particle distribution of the fiber. We performed also a morphological characterization by electron microscopy, and we also determined the typical aspect ratio or shape ratio of the fibers. This is very important for the next step, which was the optimization of the chemical treatment of that olive fiber. The idea is to have an optimum coupling between the fiber and the polymer matrix. And for having that, we tune the parameters as the concentration of the reagent in the reactor, the time of reaction, and the temperature. And so we applied a mathematical model in order to have the optimum parameters in the for the chemical treatment. We can see here on the top left a picture of the olive fiber after the chemical treatment. And on the right, we can see a reactor of 12 liters with a production of around 1 kilogram of fiber in each reactor. For the optimum chemical treatment regarding to the mechanical properties, we applied also another mathematical model. For example, for the Jones modulus, we obtain different response surfaces, as we here on the top, and also we applied an equivalent mathematical model in order to optimize the impact strength. So this mathematical tool allowed us to fulfill the requirements of the industrial users. Then we optimized also the fabrication of the compounding, and for that we applied some natural and commercial additives in order to improve the coupling between fiber and polymer matrix. We can see here some probes with on the left without fiber, and on the right with already the fiber within the material. In this case, with 25% in weight. And then we characterize those composites obtained in laboratory. We perform the microstructural characterization, the thermal characterization, also the chemical characterization, and the mechanical characterization. We can see an example of the strain curve from tensile test carried out on that biocomposite. The main conclusions in this characterization were that the requirements asked by the industrial partner were completely fulfilled. So this means we can go on with the project, and that polypropylene-based biocomposites showed a better trade-off between the different mechanical properties than the PLA-based biocomposites. So this is also an important conclusion. Then we went to the B2 action, the scalability up to demonstrator necessities. In this case, we have to scale up that we learned at laboratory scale, because we have to demonstrate that this solution is suitable for industrial application. So we have to produce around 200 kilograms of composites for each selected biomaterial. And the goal is to scale up 4 biocomposites, 1 or 2 per each in industrial case. So first of all, we have to scale up also the treatment of the fiber, the collection of the pruning, etc., everything. So we can see here on the top left an image of the pruning waste in the fields. It is in rows between the olive trees, and we apply different machinery in order to reduce the size of that pruning waste. Finally, we can have some parts with around 10 centimeters length. We contacted with some manufacturers, industrial manufacturers, in order to do the grinding, and so we reduced the size of the pruning up to the required size of the olive fiber. And we performed the chemical treatment in Andaltec. This is the chemical reactor at Andaltec facilities, and we are capable of producing around 10 kilograms per day of treated fiber. So we also had to tune the parameters of the chemical treatment, because this is in another scale different than the laboratory. In the following sub-action, we are working currently by the scaling up of the composite production, and our goal is to manufacture these biocomposites in the form of pellets. And for that, we are using an extrusion line. On the right, we can see a picture of those pellets, and those pellets have already the fiber inside. But these are our first trials. We have to optimize this process, and then we will manufacture test specimens in order to characterize them. For future stages, we will produce some prototypes, for example, for the automotive sector. There are some parts in the cars of Ford that are suitable to be manufactured with this biocomposite, for example, footrest or tailgate floor cover. And also we will produce some parts for urban furniture. This is responsibility of Matricería Peña. For home furniture, and this is in relation to the French companies Plasturia and Caliplas. So, and I would like to remark the main idea of this project, which is not specifically a research project, laboratory scale. This project has more implications. So there is a huge demand of fossil-based raw materials. This is a problem. We have a lot of bio-waste in fields. This is not a good situation. We propose, and that take the University of Jaén mainly as coordinators and researchers in the university. We propose this new technical solution, which is the use of this bio-waste from the olive pruning to produce these biocomposites. But this means also a new kind of business model, since when we have in future economy scale, this will be a very, very important solution for the industry. But also we need the involvement of the agricultural sector in order to provide the industry with this bio-waste. And also we need the involvement of the politicians, policymakers, in order to make legislation for the use of this pruning, because we need also the support of the policymakers. And also, I would like to comment that recently we have also had the contact of the Close to Market initiative of the European Commission, since they want to support us in order to create to have a commercial application of this idea. This is not only this is not a research, specific research project. This should have more impact in the society. So, regarding to the circular economy point of view, we have the agricultural sector that should in future provide this olive pruning to the industry in order that industry can produce more sustainable materials in this automotive sector and furniture sectors, but also in other sectors in future. And this will have benefits, clear benefits for the environment and also for the society. And the society should encourage farmers to provide this bio waste to the industry. So we have circular economy and also circular benefits. As main conclusions, we have already optimized the olive fiber treatment and coupling with the polymer matrices. This is technically already accomplished. We fulfilled the requirements of the industrial partners with those biocomposites, especially the mechanical properties, and we obtained pellets of the biocomposite materials perfectly. And also the scaling up of the fiber chemical treatment is already implemented. Right now, we are scaling up the compounding process at the facilities in Andaltec. And to remark that a new circular economy-based business model is really introduced. So please visit the webpage of the Live COMP0LIVE project. This is livecompolive.eu. Since we want to create networks between people from the agricultural sector, the academic sector, the industrial sector, and also the society in general. So there is a section of networking in the webpage, and we will continue disseminating these results and working in conferences in order to create a network to take advantage of these ideas of the COMP0LIVE project. On the left, you have my contact details, and on the right, the details or contact details of our partner at the University of Jaén, María Dolores de la Rubia. Thank you very much for your attention, and if you have questions, please, I'm here for your questions. So should I?
Thank you very much for that excellent talk. I'm sure there'll be some questions in the audience, but I wonder if I could start off by just asking the sort of slightly, I can understand why olive might be particularly of interest, olive prunings might be of particular interest in that part of the world, but is there any reason that this sort of model couldn't be applied to other sort of forestry products or orchards, etc.?
Sorry?
Is there anything particularly special about olives, or could you just use this? Could you extend this approach to other wood-based sort of waste products?
Yes, but the main idea is that the quantity of this bio-waste material is very huge. So we have a lot of millions of olive trees in the Mediterranean region, and also there are olive trees in other places. And this waste, so it has no price in the market. For example, if you think about the olive stone, there are some applications with the olive stone, but so it has a price in the market, but the olive pruning has no at the moment has no value in the market. So it is it creates a new market. This is on the one hand, and on the other hand, there is enough quantity of biomass for producing a lot of parts in cars. So we can provide the industry completely. So we will not have a problem of supplying or providing this with this material the industry. So the two main ideas are that we have so more than 7 million tons of pruning per year. It's a huge amount, and there is no an existing demand of that material. So economically and also environmental is the perfect idea. It could be also extended to other materials, but if you have a specific plantation for a material for obtaining these biocomposites, it is in concurrence with other plantations, but we don't have a concurrence between olive trees and other plantations. So they are already in the fields, and so there is not such a problem. Did I answer?
Yes, I mean, I was wondering if you have olive cuttings and you had sort of apple cuttings and things like that, would you have a problem mixing all those different wood waste products, or is that something that would be too complicated? I understand what you're saying about the quantity of olive cuttings, but you know, is there anything special about the size of the branches or the nature of the wood that would make it difficult to adapt?
To adapt to what?
To adapt to other woods or other wood waste.
I'm not sure if I think it is transferable to other kinds of pruning, but the thing is, how can you find such amounts of pruning in other?
I hear what you're saying. Yes, that's very, very sensible. Yes.
Yeah, the chemical treatment is adapted to this kind of fiber, but I think it is also you can do that with other kind of wooden by applying that method.
Are there other questions? Hog the questions, but can I just ask sort of an obvious one? Since we're all worried about greenhouse gases. What's the particular problem with burning the olive waste and utilizing that energy? Would that be since of course it's already that carbon dioxide has already been accounted for in the producing of the wood, as it were?
If you burn the olive pruning waste, that the carbon fixed in the pruning will again emit it to the atmosphere. So okay, you can obtain energy or heat, but if you don't burn this olive pruning, that carbon will be fixed more time in such biocomposite products. So you are delaying the return of that carbon to the atmosphere.
Yeah. I mean, it was sort of the idea years ago that you grow crops, then burn them, and then that's completely you're recycling the carbon, as it were. But it doesn't solve the problem that the level of carbon dioxide in the atmosphere is now really already far too high, I guess.
And also for example, there is a small town here in Jaén where the burning of the pruning waste in the fields is not allowed, and the reason is because they have already some pollution levels from other activities such a biomass plant, and they are not allowed to burn the olive pruning in the fields. In other regions, you can do that, or farmers can do that by applying to the administration. But anyway, when you are driving in the road and the highway, and you see the smoke from that pruning ban, it is not very nice. It is better if they don't ban that pruning. However, these are a small part of that pruning that is banned. Okay. Yeah. Another part of the pruning is chipped or grinded, and it's just covering the floors, the soil within the olive trees. Okay, so they don't take economic advantage of that pruning.
Anna, you've got your hand up.
Yes, good morning. I have a question. Do you thought about the possibility to use the olive pomace, since it is a big problem for the industry?
Sorry?
The use of the olive pomace, after the removal of the olive oil, we have a byproduct, and it is a problem to use this byproduct, and maybe you can add this byproduct to your process. I don't know, I just remember now.
Sorry, but I didn't hear which product?
Olive pomace.
Pomace?
Yes. It is the byproduct from the extraction of the olive oil from the product.
Yes, I know that in the University of Jaén there are some research groups that are working with some subproducts in the olive oil industry. I cannot say very more things about that. I don't know. But our idea is in this project is only related to the biocomposite, but it is true